first we are going to see about the RTL microarchitecture. We are all having familiar knowledge on OTG, right? So we know about USB host, USB device, and UTMA related stuff. OTG is a extra feature which is added to the USB protocol, right? So here OTG is nothing but simple intelligent mux, we can say in that way, okay? Because USB 2.0 device is there. This OTG supplement is adding a new feature to the existing USB 2.0 device. That new feature is nothing but the host capability. So it can act as a either host or device, okay? So the dual role capability is coming under this OTG concept, okay? So if you look at this slide, here we have one mux. This mux is controlled by this OTG. So the OTG controller will produce select lines so that the mux will allow either host related signals or device related signals, okay, up to this digital part. And after that UTMA part will come. This UTMA part only will have that D plus, D minus, VCC and V ground, ID pin, all those things, okay?
That OTG is connected to mugs,
right,
with from two sides. What these two sides are showing?
Yeah, if the select line is selected, host means host will send its related signals, okay?
Okay.
Otherwise device. And the third option is OTG related signals. Okay. And based on the ID signal, ID dig in the sense that ID digital signal, it will allow either USB host machine or USB peripheral machine, okay? So this is a slide which will use where our OTG exactly will going to sit. Next we are going to see about the bird side view of OTG RTL implementation, okay? If you look at this slide, you will get a clear knowledge of how we have implemented the OTG RTL, okay? In this diagram we clearly explained where in which top what are all the modules are sitting, and where ARTL, where BRTL is sitting, everything, okay? And we know that in any architecture we should have three common interfaces. First one is PHY interface, and second one is CPU interface, and third one is application interface. So application interface in the sense that we can say a memory, the part which will going to prepare data for a transaction and all, okay? And the CPU side, CPU, what it will do, CPU is nothing but we can say that is a controller which will going to control this entire architecture. So we can say it as a it will going to act like a manager. It will give commands so that this entire core will work according to that, okay? The CPU will speak through this Wishbone bus, okay? In CPU side we will have Wishbone master interface and bus. This core side we will have Wishbone slave interface, okay? That's why I mentioned Wishbone slave here, okay? So through this bus it will come and configure configuration related registers which is residing here. Now A mission or B mission will work according to that.
See, you are telling that on CPU side you are having one master, okay?
Right.
So right now you are using some real CPU like ARM processor, or you are doing some other thing?
No. Here we are not using such a kind of real processor, but instead of that we are using some software BFM.
Okay. So this means that you are mimicking the environment there.
Right.
So
We are not using any real-time processor here.
okay.
In order to test this entire core, it is enough to have a certain feature. So we implemented those features here. So it will test according to that.
Okay, fine. And coming to that CPU registers, CPU related registers you are keeping
Here.
VReg and
Right.
AReg. Okay, so those are in one memory, or those are in one module.
No, this is one module.
Okay.
This module will comprises of so many registers.
Okay.
Some registers related to A part,
Okay.
I mean A mission part, and some registers related to B mission part. Okay. So based on this configuration, B mission will work. Based on the configuration information in these registers, A mission will work. I will give you one example. We know that in session request protocol there are two possibilities are there. Device can send either data line pulsing or B bus pulsing. So the implementer may implement both the things, but the CPU only will come and tell that it is enough to have only one feature. Now it is enough to send that V bus pulsing itself, or it is enough to send the data line pulsing itself. So this core work according to that. Like that we may have some other features also. So those features are configured by CPU through this Wishbone bus.
That is okay. Like in this module, you are having certain set of registers,
Right.
where CPU will come and write.
Right.
So my question is like you are keeping some memory in which you are keeping these register, or these are distorted in this module.
Yeah, these are all separate registers, not memory.
So this is not memory mapped registers.
Right.
Okay. Okay, fine.
In real application, the CPU side, suppose 5 pin CPU side, that only controlling this thing.